In this video, we're going to talk about how to write an equation for a quadratic function written in vertex form given a couple different scenarios. So we're going to look at if we're given a vertex and a point on our graph, how do we go about writing that vertex form equation? And if we're given a graph, how do we write that equation? So first one, let's say we know that the vertex is negative 2, 5, and we've got some point on our graph 1, 32. So we're going to go ahead and look at, well, what can we plug in to our equation? This f of x or y is going to basically stay there. Same with the x, but we need to figure out what is our a, h, and k value. Well, h and k, this is vertex form, so that just comes from negative 2, 5 there. So we can write our equation with x plus 2 and then plus 5 at the end. So now the only thing left is we need to solve for this a value. Well, if we have a y and an x value from our graph, then the only thing left in our equation that's unknown would be this a value, and we could solve for that value. So that is where this other point comes in. Now this is a point on our graph, but that's what puts this plus 2 and plus 5 together in our equation. And so we actually end up getting an error if we try to plug this in to our equation. So we need some other point aside from the vertex if we're writing vertex form. So now we go ahead and substitute 1 and 32 in for x and y, and we solve for a from there. So you might subtract 5 first or simplify what's inside the parentheses. So we get 3 in there. And we could subtract 5 here. We get 27. Also simplify this 3 squared and get 9. Then divide by 9 as our last step to get an a value equal to 3. So now we know a, and if we put that in right here, that gives us our full equation. Okay. Now if we're given a graph, it's basically the same thing, but we have a little bit more to look at just to double check that our equation is correct. So we have our vertex here at 3, 1. So I'm going to fill that in for our h and k value. So x minus 3 and then plus 1. And we need to, again, use another point to solve for a. So we could use either one of these points, 1, negative 1. Since we have the points clearly labeled there, we know what those values are. The y-intercept, it looks like it's at negative 3.5, but I'm not confident with that, so I'd rather not use that as my my point that I'm plugging in. Especially if we can use nice small numbers that aren't fractions. So I'm going to use 1, negative 1 because that might be easier to use than a 5. So I put 1 and negative 1 in there. Evaluate this, I get negative 2 inside the parentheses there. I can subtract the 1 over to get negative 2. Negative 2 squared is 4. And then we divide by 4 and we get negative 1/2 as our a value. So put that back in to what we got in our first step, and here's our equation. One thing to keep in mind, once you simplify this here and get negative 2 squared, a lot of times we just kind of want to go ahead and simplify this whole thing because the a is just sitting there kind of by itself off to the side. So a lot of times we see this get negative 2 squared and we take 4 and add it to 1 and we get a 5a. And that doesn't quite work. So make sure you remember that a is being multiplied by this. So we have to get rid of this plus 1. Same thing in the first example here. We don't want to do 3 squared plus 5 and simplify that because that would give us 14, but we're not taking a times 14. We're taking a times 9, and then we're adding 5. So make sure not to combine those terms there.